In this video, you'll learn about solving quadratics by factoring when a does not equal 1 using the bottoms-up method. First, let's review the steps to use the bottoms-up method. First, you need to make sure that the trinomial is in standard form, indicating that it's solved to be equal to 0. Then, factor out a greatest common factor, if applicable. Next, you want to multiply a times c and rewrite the polynomial as x squared plus bx plus ac equals 0. Then you're going to factor as normal, finding two numbers that multiply to ac and add to b. Then you'll rewrite them as factors. Then you will divide the constants in each factor by the original value of a, simplify the resulting fraction if applicable, and if the simplified fraction still has a denominator other than 1, move the denominator up to become the coefficient in front of the variable, hence the bottoms-up method. In our first example, we have the equation 6x squared plus 5x minus 4 equals 0. The first thing you want to do is multiply the value of the first number times the value of the second number and bring it over to be the last number in the equation. So if I were to multiply the 6 times the negative 4, it would give me negative 24. Now when I do this, I rewrite this as just x squared plus 5x, and 6 times negative 4 gives me minus 24, and still set equals 0. Now you need to find two numbers that will multiply to negative 24 and add to 5. So if I list the possible numbers that will multiply to give you negative 24, remember since we're multiplying to a negative, it's going to be a positive and a negative. So you could have positive 1, negative 24, negative 1, positive 24. Then you could have positive 2, negative 12, negative 2, positive 12. If I were to divide 24 by 8, you get 3, so positive 3, negative 8, or negative 3, and positive 8. If I divide 24 by 6, you get 4. So you'll have positive 4, negative 6, and negative 4, positive 6. Now out of all of those numbers, the only set that adds to 5 is 3 and negative 3 and 8. So this is the set we're going to use to write our factors. So I can rewrite it as x minus 3 and x plus 8 set equals 0. Now the next thing you need to do is divide the original value of a by both of the factors. In this case, the value of a is whatever that first number is. So the value of a in this example is 6. So I'm going to divide the negative 3 and the 8 by 6. Now if I do that and I simplify, it's going to become x minus 3 over 6 simplifies to 1 over 2. And 8 divided by 6 becomes 4 over 3. And it's still equal to 0. Now the next part is the last part of the process where we're going to bring the bottoms up. So I'm going to bring the denominator up to become the coefficient in front of x. So it'll become 2x minus 1. And I bring my denominator of 3 up in front of x to become 3x plus 4, still set equals 0. The last part is to solve. So you could set 2x minus 1 equals 0 and 3x plus 4 equals 0. If I solve, you'll get 2x equals 1, which gives you x equals 1/2 as one answer, and 3x equals negative 4, so x equals negative 4 over 3 as your other answer. In our second example, we have 2a squared minus 11a minus 6 equals 0. The first thing we need to do is multiply that original value of a times that value of c. So if I multiply across, I'm going to have 2 times negative 6 become a squared minus 11a minus 12 equals 0. Now if I factor as normal, I want to find two numbers that multiply to negative 12 and add to negative 11. So if I list numbers that multiply to negative 12, I would have positive 1, negative 12, negative 1, positive 12, positive 2, negative 6, negative 2, positive 6, positive 3, negative 4, and negative 3, positive 4. Now the only set of these numbers that would add to give us negative 11 would be the 1n minus 12. So the factors will become a plus 1 times a minus 12 equals 0. Now this is where we have to look back at that original value of a. So we want to divide by whatever that value of a was. So in this case, the original value of a is 2. So I'm going to divide the 1 and the negative 12 by 2. Now if I simplify those equations, I'll get a plus 1 over 2 stays as 1 over 2. And a minus 12 divided by 2 becomes 6, and it's equal to 0. Now for the next step, you want to bring the bottoms up if you have any fractions left. So for first one, I can take this 2 and bring it up. So it'll become 2a plus 1. And the second factor stays as is. So it stays as a minus 6, and it's equal to 0. The last part is to solve. So you could say 2a plus 1 equals 0, and a minus 6 equals 0. If you solve as you normally would, you'd have 2a equals negative 1, so a equals negative 1 over 2 as one answer, and a equals 6 as your second answer.